Welcome to the DIY Honda Garage channel. Welcome to this presentation covering the DTC P16E2, specifically the PGM-FI-ACG LIN communication error. For the Honda Fit models from 2015 to 2020, we will be exploring the details surrounding this diagnostic trouble code, DTC, which indicates a communication issue within the linear interconnect network, LIN, system, relating to the powertrain and its control modules. This issue can affect how the engine control module, ECM, interacts with other components, particularly the alternator and power management system. Understanding the components involved helps us trace the potential causes and symptoms more efficiently. Through this troubleshooting guide, we will detail the necessary steps to diagnose and ultimately resolve the P16E2 code effectively. The DTC P16E2 indicates a problem within the powertrain control module's PCM, communication with various other components via the LIN, or local interconnect network, which is crucial for efficient operation. The primary component at risk here is the engine control module, ECM, which manages fuel delivery, ignition timing, and emissions control. The alternator, located under the hood, is pivotal in providing power to the vehicle's electrical systems and charging the battery. A loose connection, particularly at the alternator's +B terminal, can result in disruptions in communication, causing the ECM to log a fault. The LIN system communicates vital data between these parts to ensure they work together without issues. Hence, any failure in this system is significant and requires immediate attention. Several potential causes can lead to the occurrence of DTC P16E2. A common cause is a loose connection at the alternator's +B terminal, which may cause intermittent or complete communication failure. Poor connections at the PCM, which houses the computer that controls engine management, can also lead to issues. Faulty wiring in the LIN bus can disrupt communication signals. Additionally, a malfunctioning alternator itself might either not perform optimally or fail to send necessary data to the PCM. Lastly, a defective battery sensor could complicate system communication and create further confusion within the vehicle's electrical system. Thoroughly examining these areas is essential for effective troubleshooting. Recognizing the symptoms associated with DTC P16E2 is crucial for timely diagnosis and repair. Drivers may observe warning lights illuminating on the dashboard, indicating potential malfunctions. Engine stalling can occur, especially if the PCM cannot properly manage functions due to communication loss. In some cases, the battery may not charge effectively, leading to a dead battery situation. Poor engine performance is another telltale sign. The vehicle may hesitate or run roughly due to miscommunication between systems. Additionally, drivers can experience inconsistent electrical operations where components like lights and accessories behave unpredictably. Noticing these symptoms early on can save time and costs in repairs. To initiate the troubleshooting process for DTC P16E2, start by verifying that the vehicle is in the on mode, ensuring all systems are activated for a proper diagnosis. The next step involves clearing the DTC using the Auto Diagnostics system, HDS, which effectively resets the systems and prepares them for a fresh evaluation. After clearing the DTC, it's important to wait approximately 10 seconds before checking for any pending or confirmed DTCs once again with the HDS. This helps to determine if the error persists or is potentially intermittent. If DTC P16E2 is still indicated, it signals a confirmed failure, leading to further troubleshooting steps. Conversely, if no DTC is present, it may suggest a temporary issue that requires inspecting for loose connections or poor terminals, particularly at the alternator and PCM. Continuing with our troubleshooting, The next significant step is to check again for either pending or confirmed DTCs using the HDS. This is crucial as the presence of another DTC, specifically P16E3, will guide the next course of action. If P16E3 is indicated, move forward to Step 3 to further diagnose potential issues linked to the battery sensor. However, if P16E3 is not present, it signifies that the issue may be isolated to a faulty communication line. In that case, proceed directly to Step 7 to continue isolating the problem. Each of these DTCs provides essential data needed for accurate diagnosis, making this step critical in the overall troubleshooting process. In this step, begin by turning the vehicle to the off or lock mode to ensure that no electrical systems are operational, which is necessary for accurate testing. Disconnect the alternator 1P connector, which connects the alternator to the vehicle's electrical system. This disconnection is crucial as it allows for a clear assessment of any wiring continuity present. The next task is to check for continuity between specific test points. Test point 1 at the alternator 1P connector number 1 and test point 2 as the body ground. If continuity exists, it confirms that the LIN communication pathway is intact up to this point, and it allows movement to the next step in the diagnosis. If continuity is absent, it indicates a potential wiring issue or fault, leading to further complications. The fourth step involves jumping the SCS or service check short line using the HDS to initiate a short condition, which can help illuminate any issues with the wiring. This process allows for a further check on continuity between the alternator 1P connector terminal and the body ground. While doing so, disconnect these specific connectors one at a time: the 12-volt battery sensor 3P connector and the PCM connector A, 51P. If the continuity ceases when one of these connectors is unplugged, it indicates that the LIN line or battery sensor wire is operational. Therefore, the issue likely lies in the component that caused the disconnection. If continuity remains, it suggests a short within the LIN wiring, which needs to be repaired to restore functionality. This step is critical in narrowing down the area of failure. For Step 5 of troubleshooting, begin by reconnecting the alternator 1P connector to ensure that the electrical system is intact for testing. Then, move on to disconnect the 12-volt battery sensor 3P connector, as this will be tested for continuity. With the battery sensor disconnected, check for continuity between test points 1 and 2. Test point 1 at the battery sensor connector number 3, and test point 2 at the body ground. In the event that continuity is confirmed, it indicates that the alternator is likely at fault and needs replacing. However, should continuity be absent, your troubleshooting will advance to the next step to further assess and isolate the source of the issue. Continuing with Step 6, reiterate the SCS jump with the HDS, enabling diagnostic checks to avoid any distractions. This time, disconnect all relevant connectors: the alternator 1P, the PCM connector A, 51P, and ensure that the 12-volt battery sensor connector remains disconnected. Next, check for continuity between test points 1 and 2, specifically the alternator 1P connector number 1 and the PCM connector A, 51P, number 26. If continuity exists, it confirms that the LIN communication line is intact, which allows for a re-evaluation of the PCM. If the PCM does not have the latest software, an update may be needed. However, if continuity is absent, it indicates an open circuit in the LIN communication wire between the alternator and PCM, which must be repaired to resolve the issue effectively. In this final troubleshooting step, ensure that the vehicle is turned to the off or lock mode, which prepares the vehicle for testing. Again, jump the SCS line using the HDS, allowing for diagnostic monitoring while examining continuity. Disconnect the alternator 1P connector and the PCM connector A51P yet once more, preparing for a detailed assessment of the circuit. By checking for continuity between test points 1 and 2, you can confirm whether the LIN communication line is unaffected. If continuity is present, it means the wiring is intact, necessitating the replacement of the alternator to resolve the communication error. Conversely, if continuity fails, you will need to repair any identified open circuits in the LIN wire that connects the alternator and the PCM to restore the communication link. After completing repairs, based on the previous troubleshooting steps, it is vital to verify that the issue has been resolved. This starts by checking the DTC with the HDS to ensure that DTC P16E2 is no longer present. Confirming the DTC is cleared is essential, as it indicates that the issue has been successfully addressed. After clearing the DTC, perform a thorough test of vehicle operation to confirm that all systems are functioning as they should. Monitor for warning lights and assess general vehicle performance. Ensuring that no new codes have appeared and everything is operating effectively signifies that the repair processes were successful in resolving the issue in the LIN communication system. Preventive maintenance is essential to avoid the recurrence of DTC P16E2. Regular inspections of wiring connections, especially around the alternator and PCM areas, can catch problems before they escalate into significant issues. Monitoring the alternator's health periodically ensures it can maintain optimal performance and communication with the PCM. Checking the PCM software updates is equally crucial, as updates can provide bug fixes and improve functionality across systems. Finally, performing periodic system resets can help eliminate stored DTCs and undesired settings that may lead to operational issues. Keeping a close eye on these areas helps maintain vehicle health and performance, steering clear of future errors. In conclusion, DTC P16E2 highlights a significant communication error within the vehicle's LIN network, primarily involving the alternator and PCM functions. A systematic approach to troubleshooting helps identify the root cause effectively, ensuring that components such as the alternator and battery sensor are closely examined. Following the structured troubleshooting steps, from verifying DTCs to testing continuity and potential repairs, is crucial. Additionally, implementing preventive maintenance keeps communication paths clear and avoids the onset of similar issues in the future. Ultimately, being proactive can save time, money, and enhance the reliability of your Honda Fit. Please like and subscribe to the channel. See you next time.